All right, another way we are taking us around on a journey on how we can model molecules on Gauss view. Yeah, this is an advanced way, If I want to build, let's say, a molecule from the scratch, how can I build a molecule from the scratch? Let's say, for example, I want to build this 4-bromo benzaldehyde. I want to build it from the scratch without making use of the ring fragments. How can I do that? Of course, I can do that on Gauss view, but it's quite a very tedious way. Um, it's a very tedious way, and let's take a look at how we can maneuver the whole process and the whole situation. Right, what I will do is to come here, then select on the carbon atom, then I distribute it accordingly. Since I have 6 carbon atoms, I can do this: 2, 3, 4, 5, and 6. Now, that's the first thing to do. The next thing, after creating this system or these carbon systems and on this empty workspace, because the work on this workspace, we can go to bonds, and then we will then select one, and I can select carbon number 1 and 2, the bond between carbon number 1 and 2. But we know that there is resonance in benzene ring. I don't just want to draw double, but I don't want to draw the canonical structure. I want to draw the resonance hybrid. So I have to select this type of bond. So I can select this type of bond, and then lo and behold, I click on OK. We have it formed there. But don't worry about the positioning of the of the um partial bond. It would readjust itself with time. So I do the same thing with for carbon 1 and carbon 4. I apply the same principle, then I click on OK. Can you see it has adjusted? We now have the partial bond this particular inside this molecular system. We have the partial bond inside the molecular system. Then I can click on carbon 4 and carbon 5, select the same system, and then click on OK. Oh wow, it's getting interesting. Then I come here again, I select this. All right, then I click on OK. Then I come here again, I select on this, we have it there. Then I click on OK. Then I come here, I click on this guy again, select this, and then we have the benzene. Wow, it's looking like a benzene compound. Right, but mind you, we have 4 hydrogens. I can come to the elemental fragment, or to the where we have the element fragment, click on it, then click on the hydrogen atoms. Since I have 4 hydrogens, let's take it bit by bit. Then I can click on hydrogen atoms. 1, 2, 3, and 4. The nature of the bond between this hydrogen and the carbon is a single bond. So I can come here again, click on this, then I click on the single bond, and then OK. All right. Then I come here again, click on the single bond, OK. Here again, single bond, OK. Here again, single bond, and then OK. That's being done. I can now model for the bromine. The bromine is the next target. I locate where bromine is. I come back here to the workspace, and then I click on the bromine. I select the bromine atom. I place it down here. Then I look out for bond. Select the carbon to the bromine atom. Then I select this guy, and then OK. Lo and behold, we have our bromine being formed. Now I'm left with the aldehyde functional group. So what do I do? Come here again, let's take care of that by selecting the carbon atom, select on the carbon, I place the oxygen here. I can come here again, select on oxygen, atom, nitrogen. Why is that? You can come here and then select on hydrogen, select on the atom, And if you are feeling confused, you can zoom out to make it a bit smaller. Let me do that. Let me arrange so that it won't be so. Let's make it close by. Right. So now I can solve this by this my problem. The carbon is a single bond, right? This, oh, sorry, this to this. You have a single bond, then okay. Then this to this, you have a double bond, and then you have the okay. And this to this, you have a single bond, and then we have our okay. Now we have our structure being formed. From you can see the way we started right from the scratch, building the molecule from the scratch from the beginning. We can now come to this clean. The clean function is to like adjust the bonds. You can see the way the bonds are. They are not so perfect. Everything about this molecule is not yet very perfect. But the moment I press on the clean function is just like bringing down the molecule to like a grand state. Although we have not yet optimized it. It's bringing it down. It's trying to readjust the bond to the stable one that we know. So by the time I click on the claim function, now you see what is going to happen to the structures and the bonds. Everything would readjust itself. All right. Okay, we can see what has happened. The whole scenario, the whole compound has readjusted itself up to an extent. Wow. Now we have a perfect 4 bromo benzaldehyde. Then to centralize, I can come to builder, no, sorry, view, and then I click on the center. You can see the molecule is at the center, properly aligned. You can see the bonds, you can see the bromine, you can see everything about this particular molecule. That's all.